Hi guys. Okay, so I'm going to apologize in advance because this is going to be a longer video than normal, but there's some really important content in here, okay? So we're just going to jump right in, and today what we're talking about are distance and midpoints. All right, so we actually have quite a few formulas today, so what I would suggest doing is to get a note card or a piece of paper and write them down so that you can have them to reference while you're doing your homework, so you don't have to like flip back and forth, okay? But we're going to start simply by talking about the distance formula from a number line, okay? So we're putting this formula into words, but there are definitely some mathematical terms that we can pull apart in order to help us, all right, generate this formula. So the definition for the distance formula from a number line is the absolute value of the difference of the coordinates of the two endpoints, okay? So let's break that apart. So let's actually start with the first mathematical term, which is absolute value, okay? So we'll talk about the significance of that, but we're going to start with, all right, these two lines right here, which is going to represent the absolute value, okay? Now, to show this, I actually want to draw just a quick demo of what a segment is. All right, again, we're going to put those endpoints on there, all right? But because I'm not talking about one specific example, I want to make this a general idea of the endpoints of those, of the coordinates of those endpoints. So to do that, rather than using numbers, I'm going to use variables. So I'm going to use x1 and x2, all right, to represent those two coordinates. So if we go back to that definition, it says the absolute value of the difference. Difference in math means subtraction, all right, and we're going to be subtracting the coordinates. And again, we're using x1 and x2, all right, to represent those coordinates. So the absolute value of the difference, all right, I'm going to subtract x1 minus x2. And the order of that doesn't actually matter, all right? We could have done x2 minus x1, and that would be fine as well, all right? Now, the significance of the absolute value is that distance always has to be positive, right? So the absolute value is what's important there to make sure that that distance is positive, all right? So let's jump down to example 1. And again, we're looking at this number line. So it says, what is the coordinate of point B? All right. So coordinates are going to be the numbers assigned to points, right? So the coordinate for point B is just simply -3. All right. Nothing tricky about that. All right, now we're going to go vice versa, and we're going to get the point. And remember, points are named by capital letters, right? So what is the point for coordinate 5? So we're going to go to point coordinate 5, and the point assigned to that is J. Okay? All right, now, for the next one, it says, is there a point on the number line for every number between 1 and 2? And this is kind of a tricky question, because if you look at 1 and 2, there aren't any visible points in between there, right? But if you go back to section 1.1, remember that there is an infinite number of points in between any 2 points, right? So here it says, is there a point on the number line for every number between 1 and 2? The answer to that is yes. They're just not shown. There's an infinite number of points in between any 2 points, okay? Now, this last one, it says find BG. And remember, when we have the segment without the hat on it, all right, remember what that actually means is the length of BG. All right, so this is the length of BG. Now, there's 2 different ways of us doing this, okay? Let's actually use the formula that we generated, which was the absolute value of x1 minus x2, okay? So if we look at the coordinate of B, that's -3. So I'm going to plug that in for my x1. Minus G, which is 2 right here. So what is -3 minus 2? Well, that becomes the absolute value of -5, which becomes obviously a +5. So that's one way of doing it, right? But the other way is actually probably going back to like elementary stuff. How else can I find the distance from B to G? Well, I can do my little bunny hops, if you guys remember, and we can just count the number of points. All right, so I can do 1, 2, 3, 4, 5, all right, which is also the same distance that we found, okay? Okay, so we're now, though, going to go into something that's a little bit more difficult, all right, and the fact that we're not going to have a number line. We're going to have a coordinate plane, okay? So here's what I want you guys to do to follow along. I want you to plot these 2 points. Let's plot -4, 3. And then let's plot 5, -4. And then let's connect those to make a segment, okay? So the issue this time, all right, with us finding the distance between these 2 points is that it's not on a number line, which means that we can't just do the bunny hops, all right, from point to point, right? And similarly, we can't just plug into that formula of x1 minus x2 because we now have an x and a y on here, right? So what I want to do is, once again, I want to make this a general, all right, line segment. So we have 2 points, and each point has an x coordinate and a y coordinate, all right? So what we're going to do is we're going to label this first point, this top one, x1, y1, okay? And then down here, we're going to label this x2, y2. And we could have switched them. It doesn't matter which one you label x1, y1, x2, y2, as long as you keep the numbers the same. Like we wouldn't name this x1, y2. You can't do that, all right? But 1 and 1 is good, 2 and 2. Okay, so I'm going to give you what the general formula is, okay? So it's long. So we're going to start with d is equal to, which represents the distance is equal to, and we're going to make a really long square root. Okay. Now, in that square root, we're going to have our first set of parentheses, which is going to be x2 minus x1, close those, squared, plus, and same idea, y2 minus y1 squared. And all of that is underneath the same square root, okay? So this is why I would have that note card accessible, just so that it's easy to memorize. Now, let's actually put this into practice, okay? So this right here is what we're going to be using for all of our distance formula questions, all right? But now let's actually find the distance between these 2 points, okay? So let's go ahead and write down our 2 points. So I asked you guys to plot -4, 3. And then I asked you to plot 5, -4. Okay, so let's find the distance between these 2 points. So what I like to do first is I like to go across and label, all right, my points x1, y1, x2, y2, and once again, it doesn't matter which one you label as which. All right, I could have labeled -4, 3 as my x2, y2, and that's fine, okay? And then now it's just a simple plugging into our formula, all right? So let's go ahead and rewrite that long square root, and let's substitute in. So for x2, I assign that to be my 5, all right? So I'm going to have parentheses 5 minus, all right, and then my x1 is a -4. So if I do 5 minus a -4, what does that turn into? Well, it turns into plus, right? So I'm actually going to rewrite this as just 5 plus 4. Close those parentheses, squared. Plus, all right, my y2 was -4 minus my y1, which is 3, close her up, squared. All right, now let's simplify. All right, so let's bring down that long square root again. So I have 5 plus 4, all right, which is 9 squared, plus -4 minus 3, which is -7 squared. Continuing on, just simplifying, 9 squared is 81, plus 7 squared, which is 49. All right, we're going to add those together, and we're going to get the square root of 130, and we're going to leave it as is, all right? That can be our final answer right there, all right? Okay, so I'm going to pause here. Before you access the next video, try example 2 on your own, all right, and then we'll see if we get the same answers.